Today we're looking at Feynman diagrams. So basically this is a diagram to try and explain what's happening in a interaction. Okay, so we've got a penguin. Hopefully at the end of this you'll understand what that means. This is an example of a Feynman diagram. Most of the time there's no penguins in the diagram. Just some dude thought, oh, let's add a penguin into it. So there are four, what are they called? Conventions. The first one is a Feynman diagram is drawn on a space versus time. We read it from left to right, okay? So as time progresses, yeah? So that's the first convention. The second convention, we represent particles as straight line arrows in the direction of time with a letter indicating the type of particle. So everyone remember what E negative is and what is that funny VE? It's an electron neutrino. So they are both, see the arrows are both going from left to right. So matter particles go from left to right. The third convention, antiparticles go from right to left. So basically they're going backwards in time. It's just a way to express the diagram. They don't actually travel back in time. Fourth convention, which is wiggly lines are a boson. The first interaction today. This is called scattering. Here's an example of a Feynman diagram. So we're reading from left to right. So the electron is going towards the anti-electron, which is called a positive. So they're both going into each other, then they give off this thing called a photon, and then they leave each other. Okay? Okay, next one. Electron, electron. So what happens when two electrons interact? A photon passes between them. This is EM interaction because it's a photon. EM, yeah? Yeah. Okay, so they come towards each other and they annihilate each other. They turn into a photon and then they reappear. Nucleus decays into a proton, electron, and antineutrino. This is called beta decay. What is the neutron made of? Go. Correct. Which are? Up, down, down. How is that different to a proton? Proton is up, up, down. So what's happened? Up is turned into a? Good job. Let's have a look at the diagram. Here we go. We got neutron into proton. What's mediated? W, because it's weak nuclear force. Yep. And we've got a electron and a? Very good. And so this is the quark version of the Feynman diagram.